Hello there. Alright, so first please remember to check yesterday's answers in the back of the book. Odd problems, you can check your answers in the back of the book. Email me if you have any questions. And then moving on for today, 8.4 day 3. Now we're going to divide rational expressions. The good news for you is it's very similar to what we've already done with multiplying rational expressions. So starting with an example number 1 with just regular fraction stuff you've done before, you might recall that we never really divide fractions, and instead we multiply by the reciprocal. Sometimes you've maybe heard keep, change, flip, KCF as a way to remember how to do that. You keep the first fraction the same, change division to multiplication, and then flip the second fraction so it becomes its reciprocal. This creates an equivalent multiplication problem, and now we're right back to doing the same stuff we did yesterday. Here I do see an opportunity to cancel before I multiply. So I could multiply and get 12 on top and then 40 in the bottom, or I see that the 4 and the 8 can cancel each other, both divisible by 4. I get a 1 up here, I get a 2 down there. So now I can multiply my new factored numbers. 3 times 1 is 3. And 2 times 5 is 10, and there's the answer, 3/10. Same thing we would have gotten before. If we didn't do that, we would have gotten 12 over 40, and 3/10 is equivalent. So let's go ahead and take that idea, put it to practice with a problem more like what we've been working on now with rational expressions, with variables, binomials, trinomials. So first step is exactly what we just did above, and that's to change this so that we're multiplying by the reciprocal. So keep the first fraction the same, and then change this to a multiplication problem, and flip that second fraction. So the x squared minus 6x plus 8 comes up to the top, and the x squared minus 2x goes down to the bottom. So now we are back to a problem like from yesterday, and we're looking to factor this, look for some things that might cancel each other. So up top here, 4x, that seems okay for now. I'm going to leave that the same. Down here, 5x minus 20, I notice a common factor of 5. So I'm going to pull that out, and it becomes x minus 4. Now up top right here, this trinomial, that factors, it's a product of binomials. So I'm looking to set it up like this, and I'm looking for factors of positive 8 that also add up to negative 6. So this tells me they must be the same, either both positive, both negative. Now I know they're both negative, and I think minus 4 and minus 2 works out. That multiplies to positive 8, adds up to negative 6. And so then last part down here, I see a common factor of x. So I'm going to pull that x out front, and it leaves behind an x minus 2. So now that it's all factored, I look for some of these common factors that might cancel each other. The x minus 2 up here cancels the x minus 2 down there. X minus 4 right there cancels x minus 4 right there. And in fact, we left this 4x alone earlier, but now I see this factor of x down here, and sure enough, there's a factor of x right there, so I'm going to cancel them as well. Once all of that cancels, you look around and see the only things left are the 4 in the numerator and the 5 in the denominator. The rest of these canceled to 1s technically, so it's 4 times 1 times 1. And that leaves us just with a 4 in the numerator, a 5 in the denominator. That whole big problem actually had a final answer of just 4/5. So we'll try one last problem, wrap this up for today. It's problem number 3 here. And we're going to start the same way, which is noticing it's a division problem. So I'm going to use the whole multiply by the reciprocal idea, except this time it doesn't look like a fraction. So first thing you might do is there, put it over 1. And now from there, we're going to go ahead and keep the 2x squared plus 3x minus 5 all over 6x the same. Change this to a multiplication problem, and then flip this to the reciprocal. So it becomes 1 over 2x squared plus 5x. Now I'm looking to factor this numerator, product of binomials, 2x over here, and an x right there. Now I know it needs to multiply to negative 5, So I'm thinking maybe 5 and 1, one of them's positive, one of them's negative. What ends up working is if I put the plus 5 right here and the minus 1 right there. You can see how that creates the minus 5 we were looking for. And then on the outside here, that's a negative 2x. The inside right here is a positive 5x. So that negative 2, that positive 5, that's how we get that positive 3. So down to the denominator, 6x, we're going to leave that alone. Seems all right for now. Over here, the 1 is, of course, fine as it is. And down below here, I'm looking at a common factor of x. The 2 and the 5 have nothing in common, but there's some x's around. So we're going to pull one of those x's out. And that's it. With it all factored, I look for some common factors to cancel. Those 2x plus 5s cancel each other out. And that's about it. So up top here, this x minus 1 is being multiplied by 1. It stays the same. And down below, this 6x is being multiplied by x. So 6x times x, that's 6x squared. And that's it for that problem. X minus 1 over 6x squared. So go ahead and work on the new problems for today. If you have any questions, send me an email. Thank you very much.